Okay, well, most of the time these days I spend in a small room with one other person, my podcast producer, shouting into a microphone out to the world. I have very few opportunities for interactions like this one, and I've certainly never had an introduction like that one. So thank you. Thanks so much. No disrespect to the organizers, but I need this to my right for reasons that aren't interesting. Well, I'm delighted to be here. I confess, as much as teaching in the classroom is a familiar place for me, and now podcasting is a familiar place for me, I was very uncertain how to structure this talk because it's unclear whether or not people are here from the Lundbeck Foundation and or work in laboratories and want to hear about nitty-gritty data and statistics, or whether or not people want to hear about tools to better oneself or hear some stories and anecdotes. So I'm going to do all three. And I'm going to attempt to do this in relatively short thrift. For those of you that are listeners of the podcast, you'll know that I rarely am known for being concise. So I promise that I'll stop within the hour wherever I happen to be. My goal tonight really has very little to do with me and everything to do with all of you. My hope is that by the end of this hour, and then certainly after the question and answer period, that you will leave here with more knowledge about yourself than you walked in with, as well as numerous tools that you can use to optimize your mental health, physical health, and performance, because that is indeed something that we all have to take our own personal responsibility to do. And last, but certainly not least for sake of introduction, it's a particular delight to be here in Copenhagen. I have a close family member somewhere here. Wonderful. I've got who are Danes, and so every Christmas, we're a very multicultural family now. It's starting to look like the UN based on the number of different people and children and marriages and remarriages, and it's wonderful. But the Danish flag is always featured prominently on the table at Christmas and pretty much every day of the week. So it's wonderful to be here, and I very much look forward to our interactions going forward. So without further ado, tonight I want to talk about the neuroscience of health and performance. I just want to briefly acquaint you all with what I mean by neuroscience. It's the study of the nervous system, and the nervous system is not just the brain, the thing that's housed in this cranial vault, as we call it, or skull. Your nervous system includes that, of course, but also your spinal cord. It also includes all the connections between your brain and spinal cord with the organs of your body, and then all the connections between the organs of your body back to the brain. It's a loop. In fact, many of you have probably heard of the so-called Mobius strip, this kind of impossible figure that you can't tell where it begins and where it ends. That's how I'd like you to conceptualize your nervous system now and forever. In addition, there are two little bits of your nervous system that exist outside your cranial vault, and they are actually part of your brain, and those are your neural retinas, or your eyes. Believe it or not, these two little pieces here, while sometimes called the windows to the soul, I don't study souls, but they are nervous system, they are brain. They are two little pieces of your brain that were extruded out of the cranial vault during development through a very deliberate genetic program. In order to what? In order to, first of all, inform the rest of your nervous system, and therefore your body, about what's going on in the outside world, but not just in terms of vision, about how awake to be or how asleep to be. And in fact, your eyes and where you place your visual focus are the primary determinant of your cognitive focus, and we'll talk more about that. And for those of you that are low vision or no vision, you probably rely more on your hearing or touch for that purpose. But since most people in this room, I imagine, are not low vision or no vision, that's the way that you do it. So nervous system is all those bits and parts, and we're going to talk about all that. And we're going to talk about what it means in terms of health and performance. And yes, I will show a few graphs, but even if you don't have a background in biology, I promise to make this clear. All right, just a brief way of introduction. We don't have visuals on the podcast. Once I picked up my bulldog as a visual, a 90-pound visual, and that was about it. Usually it's just auditory, but here, my laboratory consists of kind of standard microscopy things. We look at small stuff under microscopes. I also teach in the classroom. students of various kinds, graduate students, medical students. We also do some kind of wacky, fun experiments that I like because I'm a bit of an adventurer. We go out into the wild and we put ourselves into weird circumstances because we study fear. So we'll go out and record great white sharks or fall off large things and then bring it to the laboratory and study that in the context of virtual reality. So we can study fear in our laboratory and anxiety and develop tools for fear and anxiety that anyone can use without having to endanger anybody, except I suppose ourselves in the process of those experiments. And then we do all the molecular biology kind of thingies, and then we also record from the human brain thanks to our friends in neurosurgery. These are patients that have electrodes deep in the brain for other reasons, and we're able to put them into some of the same virtual environments that you all will learn about tonight, and give them some of the same tools that you all will learn about tonight, and evaluate what some of the underlying machinery is that's changing as, for instance, somebody goes from being anxious to being calm, or vice versa. And then, of course, there's this podcast, which was really frankly, the inspiration came from my good friend Lex Friedman, who has an amazing science and technology podcast. He's basically legendary, yes, a wonderful person who literally lives in that suit. I've never seen him outside that jacket and tie. And it was at the end of 2021 that he said, you should start a podcast. But he said, but it should definitely not just be you talking. So I took the first piece of advice and I ignored the second. And the goal is really all of you. Right? The reason for doing it is that in 2020, we found the world in a very stressed out place. I didn't have any answers about virology, but I felt like I had a few things to share about stress in the brain, and so I started blabbing on Instagram and then the podcast. So that's what brings us together tonight. So, tonight we're going to talk about mechanisms. If that doesn't put you to sleep, then I don't know what will, but I always say, if nothing else, my lecturing will cure insomnia. And we're going to talk about cells, circuits, and chemistry, and I promise to make it accessible to everybody. And then we're going to talk about tools based on science and application, right? Not woo science. Where I come from, woo science is like the stuff that people sit on the side of a mountain, decide something works, and then just talk about it on the internet. I like experiments, I like data, and I like things that work the first time and that work every time because they're grounded in our wiring. These aren't hacks. I think this is really important. I absolutely despise the word hack or biohack. A hack is using something for one purpose that was designed for another purpose. It's a trick or kind of a sneak of sorts. But in real biology, the robust mechanisms exist in the form of wiring, cells that exist for a specific purpose, chemicals that exist for a specific purpose. And I do believe that as we learn about those, we can leverage them toward great end. Let's start with something kind of listy and boring, but let's simplify it a bit. We all exist on a continuum of arousal, of alertness, and this turns out to be very important. And we can decide, for instance, that, looks like this thing is, I was going to point to dead with an almost dead pointer, that we can be dead, that's very low arousal. We can be in a coma, that's very deep, low arousal. We can be asleep, that's very low arousal, right? Depending on how deeply sleep. We can be drowsy, we can be alert and calm, we can be stressed, panicked, and this is the stuff that gets you into trauma and PTSD. And several years ago, I decided in my laboratory to say, well, if we're going to try and tackle brain states, what should we do? And people said, figure out flow, figure out creativity, figure out awe. And I took a step back and I said, that sounds really complicated. I don't even know how to define what those things are, let alone understand them or develop tools for them. Let's go after two things. Let's figure out how to be alert and calm when we want to, and let's figure out how to be asleep when we want to. Because if we get good at accessing those two states fairly deliberately, much of life goes much, much better. All I have to do is deprive you of sleep for a day or two, or deprive you of your ability to stay alert but calm in stressful circumstances, and very soon your life is not going to look so good. All you have to do is know how to be alert but calm when you need to be, and be asleep when you need to be, and your life is going to get far, far better. I know that because there are literally tens of thousands of quality peer-reviewed studies that support that. So every time you read that sleep deprivation gives you Alzheimer's, which it doesn't, by the way, or that sleep deprivation makes you stupid, which it doesn't, or that sleep deprivation disrupts your metabolism, which it does. Every time you hear about something like that, what you're talking about is a sort of a foundation. It's sort of, think about your nervous system and you as kind of a buoy in the water, and you want to have buoyancy. And when you're lacking sleep, it's as if you're drifting down, 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 down. You don't have that kind of buoyancy that you need. So sleep is the ultimate restorative. So without getting into too much more science for the time being, let's get into some tools. And I want to just offer you the simplest tool that I know, but it's also the most powerful tool that I know based on dozens, if not hundreds, of quality peer-reviewed studies, both in animals and in humans. And this is work that there are far too many laboratories to credit, but here's the deal. Every cell in your body has a 24-hour clock at the level of genes, at the level of chemicals. It's a little clock. Every cell in your body needs to be synchronized with one another in a very particular way. And if it isn't, you experience intense stress or mild stress or emotionality. Some of us are more resilient than others to these shifts, but it doesn't just happen in the case of jet lag. If you are not in training, as we say, or matching your body's clock to the external light-dark cycle, regardless of whether or not you live in Scandinavia or in Brazil, you will suffer. And if you do match your internal clocks to the external light-dark cycle, most days, you will greatly benefit in the form of two main things: alertness and energy in the daytime, including cognitive ability, and your ability to sleep at night, which is this incredibly powerful restorative. So how do you do that, and why do you do that? I'm going to just briefly summarize. In your eyes, which again are two little pieces of your brain, you have a specialized set of neurons. Again, neurons are just nerve cells. Those nerve cells, as you know, are responsible for vision, pattern vision, edges, faces, colors, motion, etc. But there's a very ancient system of what are called the melanopsin intrinsically photosensitive ganglion cells, which is basically just nerd speak for neurons that don't care about patterns. They care about a particular quality of light that's available twice a day, every day. Yes, even in the dead of winter, even in Scandinavia, but certainly in the summer and certainly in the fall months. And the pattern of light that I'm referring to is yellow-blue contrast. Yellow-blue contrast is present in the sky when the sun is at so-called low solar angle, low in the sky. And beautiful work, mainly from groups at the University of Washington, and I'll just give credit to Jay and Maureen Knights' lab. This is a husband and wife team that work on color vision, and they and their students, of course, have identified a specific set of neurons in the brain and eye, in the eye, which is brain, that detect these contrasts between blue and yellow. And what I'm going to tell you is that if you view low solar angle sunlight in the morning, it doesn't have to be right at sunrise, but while there's still that yellow, blue, sometimes orange hue in the sky, and again in the evening, you do something extremely powerful for your entire nervous system and for your entire body. First of all, what you do is you trigger the timing of an increase in a hormone called cortisol, which is sometimes thought of as a stress hormone. But cortisol is responsible for you waking up in the morning. It activates your immune system. It also increases your core body temperature, which then makes you able and willing to engage in physical activity and mental activity, and on and on and on. It's cortisol levels that are out of check, that are too high, or occur at the wrong times that are a problem. In fact, by viewing low solar angle sunlight early in the day, you time this peak in cortisol and temperature to shortly after awakening. And if you don't view that, there's a delay, there's a shift in that cortisol peak, and it turns out that a late shifted peak in cortisol is actually a signature for two things. One, depression, low level or major depression, and also one of the signature features of depression and anxiety problems, which is waking up at 2 or 3 in the morning and not being able to fall back asleep. One of the classic diagnoses of depression. So viewing low solar angle sunlight in the morning is absolutely crucial. It's also crucial to view it in the evening, but more important to view it early in the day. It sets in motion a huge number of biological cascades, leading to all the good stuff that I talked about. Now, a couple of things, because I always get asked the same questions over and over, so I'll try and preempt those now. Do not wear sunglasses while doing this. I'm actually quite delighted to walk around Copenhagen this week and see that very few people actually wear sunglasses. Terrific. They clearly either understand this or maybe it's just an unconscious genius that exists in Scandinavia. Second of all, it's fine to wear eyeglasses or contacts. In fact, they focus light onto the retina, more precisely, even if they have UV protection. It is not blue light per se that triggers this mechanism. It is blue-yellow contrast. Now, here's the really cool part. Even when there's dense cloud cover, these wavelengths of light come through, which raises a very interesting idea, which is that color vision evolved first not for detecting colors consciously, but rather for entraining, matching your nervous system and the activities and sleep of your brain and body to the external light-dark cycle. If that sun gets overhead, you are in what's called the circadian dead zone. You cannot activate and shift your clock. Doesn't mean that getting light throughout the day isn't a great idea, but you can't shift your clock in the middle of the day in the same way. So this yellow-blue thing turns out to be a primordial and ancient way of establishing a relationship to the world. And this is not about getting in touch with nature, although it will do that too. This is about nature getting in touch with you so that your entire nervous system can function well. The other thing that early yellow-blue contrast does is it sets in motion a timer for the increase in a hormone called melatonin, which I'm sure many of you heard about and probably some of you are taking. Melatonin, in addition to being a supplement, is a hormone that's secreted by your pineal, which Descartes called the seat of the soul for no other reason except that it was the only the only structure in the brain that wasn't on both sides, it was right in the middle. I don't think that experiment's ever been done, but that's what he thought. But it secretes melatonin, which is a sleepiness hormone that helps you fall but not stay asleep, which is why I'm not a fan of taking melatonin except for the treatment of jet lag. It doesn't help you stay asleep, it helps you fall asleep. And frankly, the dosages of melatonin that are out there are far greater than you probably want to be ingesting. It also does other things, like it inhibits the onset of puberty. But if you've been taking it, don't worry, because these effects seem to be reversible. And who knows, maybe delaying puberty is a good thing. I can see parents now trying to say, just keep them out of their teenage years, right? I was a wild one as a teenager, as some people in the audience know, but I eventually recovered. So spontaneous, it wasn't spontaneous, unfortunately. Okay, so view low solar angle sunlight. If you wake up before the sun comes out, turn on as many bright lights as possible if you want to stay awake. Incredibly powerful mechanism. I wouldn't put it here as the first slide. I wouldn't suggest it to as many people as I have if it weren't an incredibly powerful mechanism. Do you have to do it every day? Most days, 80% of days. And if you do it for 5 minutes one day and 10 minutes the next, great. On a cloudy day, stay out for 15. But here's the thing. It's a slow integrator mechanism. So basically what happens is if you miss a day or two, you have to get outside for about an hour to reset this on the subsequent day. So be consistent with this practice. Very easy. It's actually a very pleasant practice. And for those of you that live in environments where you can't get this inside, just get outside. Just 5-10 minutes. Incredibly useful. And then there are a few other things there that I put for those of you that have trouble with sleep. And we could talk as much about sleep as you like. It's a favorite topic of mine. Here in Scandinavia, you're quite good at understanding that setting lights low in the room is a good idea if you want to be sleepy. Overhead lights, not so much, because these cells tend to view the upper visual field. Why? Because they're designed to view the sky. Okay, so doing this will help you, I promise. And of course, sunlight is wonderful, and there are other lights that can do this if you truly don't have access to sunlight. Okay, now I want to talk about stress, because stress is something that is a fundamental problem for mental health and physical health of all kinds. You know, I've actually grown rather tired of seeing papers that say stress worsens the symptoms of cancer, because of course it does, right? It diminishes all the basic biological functions, including sleep, which then disrupt cancer, which disrupt metabolism. And so, you know, there are tens or hundreds of thousands of papers on this, but what's the deal with stress? Obviously, we have a stress system. We don't have to learn how to use it, unlike our calming system. That's a little trick that evolution played on us. But there are ways to control stress, and this is something that my laboratory has spent an immense amount of time on. I worked in animal models for a long time, and it was in 2016 that I decided no more. I'm kind of winnowing down my work on animals, despite I think the value of certain kinds of animal work. I want to work on us, right? The other old world primates. Because there seemed to be so much confusion in dealing with stress and how to deal with stress, in particular when we're stressed. And that's sort of the paradox. When we're stressed, it's actually much harder to regulate stress. We all know, get good sleep, get exercise, eat well, social connection, avoid toxic people, stay off social media if you're being trolled, et cetera, et cetera. But what happens when you're stressed anyway? Because that happens. Well, we wanted to design real-time tools you could use in the moment, and then ways to make us tougher. Not cut off from the world, but tougher. Indeed, there was so much discussion and beautiful books, by the way, on grit, resilience, and mental toughness. But what is that, really? Does that mean being detached? Or does it mean that you can tolerate things and respond in an adaptive way? And in the new agey culture, you'd hear things like, be responsive, but not reactive. Okay, like where are the cells for that? I love the concept, but what am I supposed to do with that? How do you tell a 6-year-old, be responsive, not reactive, right? Or a 60-year-old for that matter. And I would also argue that a lot of the ailments of the mind and body, but also a lot of the terrible things that happen in the world are the consequence of unregulated stress. Other things too, like unregulated narcissistic personalities, but also unregulated stress. So, it's always interesting. There's sort of a growing movement against narcissists, right? The mark of a scientist who's a narcissist, by the way, is somebody that refers to themselves in the third person. We used to play this game when we were graduate students, when anytime someone there's a Max Planck director that does this, so I'm not going to call them out. Every time we kind of score a point, and you try and see who could get the most points at these meetings, and indeed it's the case. But then again, I named my podcast Huberman Lab, so forgive me, you know. So okay. Leveraging respiration physiology. So somewhere around 2018, there was a great movement that happened. I don't know why it happened. I think we can credit a number of people, maybe Wim Hof to some degree, who I know and have had the great pleasure of spending time with, but others as well have been talking about the power of respiration and breathing for a long time. The problem for me as a scientist is that most breath work was done sitting in the lotus position, eyes closed, or sometimes staring up. And, you know, it was hard to talk to people about because people thought, wow, that's really wacky. And people look strange when they're, you know, it looks weird. And so a lot of people kind of, oh, that seems kind of like sorcery. It's almost as weird as meditation, but even weirder because you're making noises. And what I decided was, you know, I don't know about breath work. We'll talk about it in a moment. But I am interested in what I can do to regulate stress in real time. How can I regulate stress in real time? Because I'm no stranger to that, right? I'm human like all of you. How can we do that? Well, it turns out that there's a beautiful mechanism. Again, not a hack, but there's a beautiful mechanism built into all of us. And the physicians in the room will notice this from their training. So this is basically an MRI of breathing. It's a paper on the diaphragm, which is the skeletal muscle, much like the muscles that move your limbs. And there's an interesting phenomenon that occurs in all of us, and that's, of course, the heart. When we inhale, this incredible muscle, the diaphragm, moves down. And as a consequence, there's more space in our thoracic cavity. And as a consequence, the heart gets a little bit bigger when we inhale. Believe it or not, the heart literally gets a little bit bigger. Watch this. You can sort of see the volume increase. And as a consequence of that, blood flows a little bit more slowly through that larger volume. And as an immediate consequence of that, the nervous system sends a signal to speed the heart up. Conversely, when we exhale, the diaphragm moves up, the heart gets a little bit smaller. Just for a moment, blood moves more quickly through that smaller volume, and a signal is sent from the nervous system to the heart to slow the heart down. That slowing down of the heart when we exhale is a signature. In fact, I would argue it is the signature of the parasympathetic, the calming nervous system. And so in thinking about breath work, I thought, well, I don't want to think about breath work. I want to think about respiration physiology. This has a name. It's called respiratory sinus arrhythmia. And indeed, there are other mechanisms that control speeding and slowing of the heart. So to the physicians and scientists in the room, I acknowledge that. But this is a powerful one. What it means, and turns out to be the case, is that inhales increase your heart rate and exhales decrease your heart rate, which means that your pattern of breathing can be used in a deliberate way to control your level of so-called autonomic arousal, to move you from drowsy to alert, or from panic to alert but calm. Now, how are we going to test this? So I partnered up with a colleague of mine in psychiatry, Dr. David Spiegel, he's our associate chair of psychiatry, not the psychiatrist Dr. David Spiegel, who was featured in the Amber Heard Johnny Depp trial recently. Very unfortunate that they kind of look a little bit alike, but don't tell the David that I know that I said that. The only positive consequence of that coincidence was that the episode with our David Spiegel on the Huberman Lab podcast got a lot of views in the last month. But anyway, our David Spiegel is brilliant. I don't know the other David Spiegel or his work, but we don't have anything to say about the Amber Heard Johnny Depp mess. What we did have to say was, there have to be ways that you can breathe to control your nervous system, and this can be done deliberately. And just as brief, this is just like respiration basics, and I don't expect you to remember all this, but your lungs are not just two big bags of air. They have these hundreds of millions of little tiny sacs. And on the inside of those sacs, they're hollow, but they're kind of fluid lined, like a balloon with a little bit of dampness on the inside. Why so many of these sacs? Well, if you were to lay them all out, they'd be bigger than this stage, as big as a tennis court. And they allow a lot more oxygen to be brought into your lungs, and they allow a lot more carbon dioxide to be offloaded when you exhale. A lot of your sensations of stress and shortness of breath has to do with buildup of carbon dioxide in your bloodstream. And when you inhale, you bring oxygen in, and these little sacs are amazing. They interface with the blood so closely that they actually allow oxygen to move into the bloodstream, and they allow carbon dioxide to move out of the bloodstream. So on inhales, you're bringing in oxygen, obviously, and on exhales, you're offloading carbon dioxide. Turns out there's a particular pattern of breathing that you do all the time when you've been holding your breath, or maybe if you've been mouth breathing too much, or you're under breathing, or sometimes if you're breathing too much, you're hyperventilating. What happens is you'll do a so-called physiological sigh. I did not discover these. These were discovered by physiologists in the 1930s. It is a double inhale followed by a long, full exhale. And you do that spontaneously every 1 to 5 minutes in sleep. Animals do it before they go down to sleep. You do it if you're claustrophobic. You don't know that you do it, but you can do this, and it turns out to be a very powerful mechanism. Sighing is caused by this innate reflex, and it also occurs in yawning. And no one knows why that's contagious. No one knows. Probably a combination of environmental stuff like shifts in whatever's in the atmosphere, time of day, but also probably something visual. Nobody knows. There's another thing that turns out to be really important, which I didn't discover. As you notice, most of what I'll talk about, I didn't discover. I actually prefer to talk about other people's work than our own. And that's nasal breathing versus mouth breathing. And if you haven't seen or read the book Jaws by Paul Ehrlich and Sandra Kahn at Stanford, this is a remarkable book. Also, James Nestor's book, Breath, New Science of a Lost Art, came out. But this is an academic book written by two amazing academics who are my colleagues, with a foreword by Jared Diamond and an intro by Robert Sapolsky. So a lot of heavy hitters on there. And it turns out that as long as you can, you should try and be a nose breather. This is especially important for kids. Mouth breathers, their chin, if you kind of measure the distance between the chin and the neck, it's shorter, and it obstructs the airway, and it causes all sorts of issues in the sinuses, leading to droopiness of the eyes and tucking under the jaw, sleep apnea, and more prone to infection. And if you don't believe me, I'm about to show you a timestamp between one young individual who was shifted through a combination of simple tools that you can use, if you like, from nose breathing to mouth breathing across 18 months. Now, of course, this was during development, but this is pretty striking. Mouth breather on the left, nose breather on the right. And there are numerous examples of this in this book. And it's a really striking phenomenon. The other thing that seems to be really important is not slurping all your food, but also chewing your food. They've done some beautiful twin studies of people who twin separated, one that chews on things and the other one is just kind of slurps things down and is a mouth breather. People who get allergies and can't breathe through the nose. Here's the deal. If you have trouble breathing through your nose, breathe through your nose more. The sinuses dilate. Some people put medical tape on their mouth while they sleep. Some people learn to fall asleep with their hand over their mouth. And as I always say, there are a lot of reasons to keep your mouth shut in life. It can save you a lot of trouble. We rarely get in trouble for what we don't say, right? Rarely, sometimes, for what we don't say. So physiological sighs and nasal breathing turn out to be really powerful for not just cosmetic features of the face, but also some health metrics. We decide to study this. So this is kind of a video of deep inhale through the nose. Then the second one is, so it goes like this. I'll just do this because I've done this so many times. I'm beyond embarrassment at this point in my life anyway. So it's a big inhale followed by a short little inhale where you maximally inflate the lungs. Why? Remember I told you those little sacs are fluid lined on the inside? It's like trying to blow up a balloon at a kid's party. If you give one big push, doesn't do it, so you go, and then it pops open, and then you can fill it. And then when you exhale, it's a full to dump all the carbon dioxide. As far as I know, based on data, this is the fastest way to calm down when you or someone else is stressed. And this also tells us that never again tell someone to take a deep breath. You want 2 deep breaths through your nose plus a long exhale. It's the first time anyone's laughed at that, but you're right. It's hilarious, right? Take a deep breath. Also, never tell someone to calm down. That never works. Think about what happens when you inhale. Heart rate increases. So telling someone who is very stressed to take a deep breath is basically telling them to increase their heart rate. Telling them to take 2 deep inhales through the nose is the fastest way to bring your nervous system down. And of course, we have data to support this. This isn't just something that we came up with. This, by the way, is a ratio of 1 and then maybe a quarter breath and then a long exhale, maybe twice as long. It's not an absolute. These aren't seconds. That's a ratio of 1 to 0.25 to 2. Okay? We did a study. This is supposed to look complicated. Don't pay attention to the details. A lot of subjects. We had people meditate or do what I just described, which is called cyclic sighing. We had them do that pattern of breathing, but repeatedly for a few minutes each day, or do box breathing, which is just inhale, hold, exhale, hold for equal ratios. There's a way to figure out how long that should be. It's called carbon dioxide tolerance. We can talk about it in the Q&A. But in any event, it's a tool that freedivers use. Have you ever noticed freedivers are like the calmest people in the world? They also don't tend to live very long. So it's not a sport I highly recommend. And then there's cyclic hyperventilation with retention, also called Wim Hof breathing, Tumo breathing, pranayama breathing, kundalini breathing. This is the hyperventilation followed by if you're Wim, right? And it actually has a very specific use that is research backed, that is pretty incredible, but we'll talk about that in a few minutes. So we ran this study with more than 100 subjects. What did we find? I'm going to just summarize the data briefly. Here I'm trying to incentivize you to do certain kinds of breathing. What does all this mess mean? Well, it turns out that we had people do this for about a month, and what we found was their positive affect, their feelings of well-being, their sleep, their mood, all improved, their resting heart rate decreased, and their heart rate variability increased, which turns out to be an indirect measure of control over your parasympathetic nervous system, an ability to calm down. Pretty powerful for 5 minutes a day. So this is a real-time tool, or it's something that you can use otherwise. When we compared it to mindfulness meditation, it turns out it performed better, quote unquote. But meditation was still useful, even just 5 minutes a day. We'll talk more about meditation a little bit later. This is pretty funny. Before I came out here tonight, they handed me these and they said, can you handle both? One's the thing. And I said, look, I'm an old world primate, but as far as we know, Homo sapiens are the most advanced, and I still can't figure it out. So I'm going to just leave that over there. So much for that. So can you use stress to fight stress? I just talked to you about real-time tools. Well, our David Spiegel, again, not the Amber Heard David Spiegel, Amber Heard Johnny Depp trial, for which I do not have a stance, by the way. I didn't watch it. That kind of stuff just makes me feel uneasy about lots of things. David once said to me, and I had to write it down, because if I'm ever talking to you and I just start writing something down, I might be texting something else, but more likely you said something really intelligent and I want to capture it. But I'll credit you, like I will do David now. When it comes to tools for managing stress, anxiety, and even trauma, it's not just about the state you are in, but how you got there. We can handle stress, but how we got there is key, and whether or not we had anything to do with it. The distinction between trauma and non-trauma is one of confusion in the nervous system. If you look at the psychology and you look at the physiology, it's one of confusion about who was responsible for putting us in a given state. When we direct our own stressful states, it's very powerful. You say, why would I want to make myself more stressed? That sounds horrible. I'll tell you why. Because if you deliberately induce a state of stress and you deliberately anchor your thinking and remain calm in that state of stress, you gained yourself a superpower for when you go back into life and stress hits, which it inevitably will. Now, I know that there are a few people in this audience that probably do this naturally. They're just very calm, right? I had a bulldog for a long time, Costello. Bulldog is an amazing animal, right? Its level of parasympathetic tone, meaning its tendency to want to be stationary or still, is beyond any other animal on the planet. It's like it's bested only by the barnacle, which doesn't actually move. Those things just stick to the sides of ships. But most of us are a bit more like, like this sometimes or calm sometimes. And learning how to raise your stress threshold can be very powerful. So there's another pattern of breathing, and it's the one I just described. If you are comfortable doing this, we're not going to do this now, but if you're comfortable doing it, meaning you're not concerned about having an anxiety attack, and I'm being serious now, or a panic attack, you want to explore this, you can get better at dealing with stress, not just in real time, but by inducing stress deliberately. What's a great way to do that? Well, you have one task. You need to release adrenaline into your nervous system, also called epinephrine. And that happens in the brain and in the body. And the way to do that is 25 hyperventilating breaths. So you're inhaling deeply, and then you're gonna just let the air fall out of you. Inhale deeply and then fall out of you. 25 times you will be warm and agitated, and that warm agitation is adrenaline. And then you hold your breath for about 15 seconds and repeat it 2 or 3 times. By the end of that 3 rounds, as we call it, you will be very alert and very activated. I promise. And your task then is to try and achieve a state of mental calm. And what then happens is your nervous system learns, you learn, that when adrenaline kind of juts into your system to maintain clarity of mind, something that, at least to my knowledge, never is maladaptive and is always adaptive. Whether or not you want to respond, react, fight, flee, any of the F's, that's a wonderful ability to have. And guess what? You've heard that stress depletes your immune system. Nothing could be further from the truth. Stress activates your immune system, at least in the short term. How else would we be able to care for a loved one for many nights on end, or study or work very hard for a deadline? Have you ever noticed you'll do that, go, then you'll rest, and then you get sick? Because your immune system is activated by adrenaline and by stress. And some amazing scientists, amazing because they had the guts to do the experiment at a time when no one was talking about this stuff, had people do that pattern of breathing or meditation, brought them into the hospital, and injected them with E. coli. Not a study I want to be a part of. I don't know what they paid them, but they're Dutch. I'm not casting any judgment, just they signed up. The group that did meditation, fevers, vomiting, diarrhea, as you would expect. The group that did that pattern of breathing, far fewer, if any, symptoms. Amazing. Adrenaline is a powerful molecule, and if you control it, you are going to be better off. What are some other ways that you can raise your stress threshold and activate your immune system in this way? Well, deliberate cold exposure is pretty popular now in some places. Some people hate it. I like hot showers. I like swimming in cold water. Who am I showing here? This, I think she's in the audience tonight. We've never met. This is Dr. Susanna Soberg, who did her PhD thesis not far from here on the metabolic effects of deliberate cold exposure. The citation is there. It's a beautiful paper, one of my favorite papers. Altered brown fat thermoregulation, enhanced cold-induced thermogenesis, young health, winter swimming men. There's no reason to think this doesn't also exist in women, but by getting 11 minutes per week total of cold water exposure, typically immersion. How cold? I always say, cold enough that you really want to get out, but you can stay in without dying. That will differ for you and for you and for you and for you. So start slowly, be careful. And don't do it in open bodies of water at first. Cold showers work, but they're harder to test in the laboratory for obvious reasons. Has a bunch of other effects, metabolic effects. It tends to make you feel more warm when you're out of the cold. You build up this reserve of a kind of it's a healthy fat, brown fat, increases metabolism. It's also cold water is a great way to trigger adrenaline release. And yes, you're gonna hate it every single time. If you like it, I kind of wonder about you. Nobody likes it. That's the point. That's why it triggers adrenaline release. But the beautiful thing is, you warm up afterwards. There are 2 ways to do that, and I'll explain in a moment. And there are now data published in the European Journal of Physiology some years ago. The increase in dopamine, a molecule which generally makes us feel good and alert, and epinephrine, which makes us feel focused, 2.5x increase in dopamine and norepinephrine. And my colleague Anna Lemke at Stanford, who runs our addiction dual diagnosis clinic, wrote an amazing book called Dopamine Nation. I'm not here to promote Stanford books or Stanford people. It just so happens these are the people I'm surrounded by. And if you want to learn more, you can. I don't get a cut. I don't care about any of that. It's just a brilliant book. And she talked about patients that have used deliberate cold as a way to wean themselves off of even drugs like cocaine, which of course also increase dopamine, but in a very sharp spike kind of way, not this long arc of dopamine release. So this is a powerful tool. Are there other things that can do it? Sure. Cyclic hyperventilation is another, but cold water always works. The colder, the better, provided it's not so cold that you shock yourself into, cardiac arrest. And I'm being serious there, so I'm kind of offering a warning, not to protect me, but to protect you. Should you warm up afterwards? Well, I like to run for the hot shower afterwards, or the sauna. That's my thing. But there's now a principle which I named because it's not named after me. So I like to name, in science we like to name things after each other. So there's a principle which I call the Solberg principle, which is if you want to increase your metabolism further, use your natural warming mechanisms to warm up. Get out of the cold and just stand there quaking until or clothe up again, dry off. If you're like me and you can't think about it, metabolism or anything when you get out of the cold because you just want to get warm again, then just hop in the shower to get warm. Okay? So the Solberg principle says that if you want the maximal effect on metabolism, dopamine and epinephrine, warm up naturally. And I think, I think Susanna has a book out now. I don't know if it's in English, but I think it is in Danish. So I have yet to read the book because I don't read Danish. Now I'd like to talk about neuroplasticity, and I confess I have at least one major neurologic defect, which is that I lose track of time. So I'm going to look at my watch, but not out of boredom. That would be weird if I was bored with my own talk, but simply to orient myself. And I realize I'm running slow, so I'm going to speed up. I'm going to talk a little faster. I also will take whatever time to get through your questions. Obviously, punctuality is also not my forte. Neuroplasticity is by far the most amazing property that our nervous system has. So our nervous system is a prediction machine. It wants to understand what's going to happen next, and it builds those predictions through experience. It also has components that are designed to make sure that you're breathing, make sure that your heart beats, make sure that your digestion works, etc. But neuroplasticity, the nervous system's ability to change in response to experience, is by far, I would argue, the most impressive feature of this incredible organ that we call the nervous system. And beautiful work that was done in the 70s and 80s and that earned two guys, David Huvell, a Canadian, and Torsten Wiesel, a Swede, the Nobel Prize, showed that early experience from about birth till about age 25 powerfully shapes our nervous system. And my favorite example of their work actually was not done by them, but was done by a brilliant student of theirs, later turned probably one of the world's finest neuro-ophthalmologists, Jonathan Horton, and then this guy, Adams. Adams, you don't know, but you will know, because he's the guy at Neuralink that Elon's got trying to figure out how to tune our brains up differently. So that's where these folks are now. What are you looking at here? This is a piece of brain that's laid out flat after death, fortunately, and it has this spiderweb-like picture on it. Turns out that this is the eye of the same individual, and those are the blood vessels in the eye. And these vein-like protrusions are not veins. Those are darkly stained areas of neurons, probably thousands and tens of thousands of neurons in each one of these little strips and in between, that reflect high activity of neurons, lots of electrical activity of neurons. What this image means, because this matches this in very interesting and precise ways, is that in each and every one of your brains, and in my brain too, there's a fingerprint of your early experience. What was the experience that led to this? Those blood vessels cast shadows onto the eye, and those shadows are actually reflected in the architecture of the brain. So right down to the detail of the particular patterns of blood vessels you have in your eye, your brain is a map of experience. And there was a bunch of other experiments and more experiments that indeed prove that from birth to about age 25, just passive exposure to life creates a map in your brain of prediction, what the world will look like, what the world will sound like, what individuals with a particular face will be like in a particular circumstance. That's what your brain does. Besides all the housekeeping stuff of keeping you alive and digesting, etc., it keeps you predicting things more or less accurately. Now, that's great, and thanks to Torsten and David, their beautiful work. We now know that the brain can be shaped early. So for instance, a child can learn, 2, 3, 4 languages without an accent early in development. Try that after 15 or 20, much, much harder. What else do we know? We know that if you learned a skill or a language early in life, and then you don't engage in that skill or language, and then you wait until late adulthood, you can activate it very easily. I haven't been on a bicycle in years, and I confess I didn't do it this week, but I know how to ride a bike from way back when, and if I hopped on a bicycle, at least if I was careful about which street to do it on in Copenhagen, I'd ride. Because that map, that understanding is there. Okay? That map is basically a prediction about what to do when the bike leans this way or that way, or someone comes at me, et cetera, et cetera. Beautiful work done mainly in the 90s shows that there is plasticity in the adult brain as well. So after age 25, you can get plasticity, but there are very specific requirements. This is a pretty technical slide, but I'm going to make it simple for you. These are just images of the brain, different individuals, and those dark areas are areas of neurons that respond to a particular frequency of sound. In this case, a sound of about this frequency. And then outside those dark areas are neurons that respond to a different frequency, like this one. Okay? So every time there's a versus a, and obviously I don't have perfect pitch, I have zero musical talent. That's about all the music you're going to hear from me tonight. What they found is that if you record from those neurons, you play that tone, nothing changes. You have a map of the auditory world in your brain. However, if you reward subjects to pay attention to a bunch of tones, and every time they hear that, they hit a button and they get a reward, what you find is pretty quickly that representation of that sound grows in the adult brain. And you can see that evidenced by a lot more dark stuff. Now, here's the important part. It's not just passive exposure. How do we know? Well, if they have subjects listen to and their task is to pay attention to the patterns of bumps on a rotating drum, and that's what they're paying attention to, nothing changes in the auditory cortex. Nothing changes because they weren't paying attention to the relevant stimuli. So what does this tell us? This tells us that the adult brain is plastic, but that you have to focus as an adult if you want neuroplasticity. So for 25 plus years, we've been kind of stumbling around as the general public, going, oh, I thought you can learn really well as a child, true, but that learning as an adult is much harder. It is harder, but if you meet the specific requirements, it happens. And my colleague at Stanford, Eric Knudsen, has shown that you can get as much plasticity in the adult brain as you can in the juvenile brain, provided that you have these elements of focus and attention, and one other thing which I'll tell you about next. I'm going to skip that for now. The other component of plasticity, and this is important, is that no biological event is an event, it's a process. Neuroplasticity is triggered by focus. In fact, focus is a key thing that happens most often when you failed in your last attempt. We'll talk about this. A failure to do something correctly, that's increasing your focus. It's signaling to your nervous system something needs to change. Because if you can perform everything correctly, like use these 2 remote controls, then there's no reason for your nervous system to change. So when you're trying to learn a language or a physical skill and you're failing, well, that's a signal that something needs to change, and it translates to a neurochemical signal. How many failures, what percentage? Well, it turns out a failure rate of about 15% is the proper level of difficulty. So teachers, coaches, give people the opportunity, give kids the opportunity to get it right about 85% of the time, and then that 15% or so. This is based on computational modeling. It's not a perfect number, okay? So That's great. You get focus. It triggers the plasticity, but it doesn't ensure the plasticity. And since this has been sitting behind me for the last minute or two while I've been blabbing, you already know that the actual rewiring of neural connections occurs in sleep. And here are just a few citations that support that in a couple of different species, including humans. During sleep, there's sort of two major phases of sleep. And here I just want to give a nod to my friend and the amazing Matt Walker that wrote Why We Sleep, an incredible book, an incredible research program at Berkeley. And of course, there are many others doing incredible work. But I think Matt was the first one to really just kind of step out in the world and says, listen, everybody really needs to sleep. And right now, at this point in history, we all go, yeah, of course, we know that. We largely appreciate that because of Matt and his willingness to take a few on the chin in the process of doing that. So a lot of respect for Matt for doing that. What happens in sleep? Well, in the first half of the night, it's mainly physical repair. Mainly. And in the second half of the night, you have these intense dreams, more rapid eye movement, sleep. And guess what? You have these intense dreams, but your body cannot secrete adrenaline during those intense dreams. So there's an uncoupling of emotional experience and bodily experience that leads, we now know, to a reduction in the emotional weightiness of traumatic and difficult events. So that second half of the night sleep is really critical, and I can prove this to you by depriving you of it, and you will become an emotional wreck. You will also find that life's events are much more overwhelming without that second half of the night sleep. Now, I don't want to overwhelm you about sleep and give you sleep-induced anxiety about sleep. That's why you need to do the morning light viewing and learn how to control your stress. Neuroplasticity also occurs during so-called non-sleep deep rest. Now here, admittedly, I came up with this acronym because scientists love acronyms, called NSDR, non-sleep deep rest, because I wanted to kind of wrap my arms around a bunch of activities like, forgive the name, yoga nidra, which means yoga sleep, or certain forms of self-hypnosis, or certain forms of breathing that are designed for you to deliberately calm yourself. And if I started saying things like yoga nidra, unless you're in Northern California, people kind of back away slowly, right? And I do a fair amount of work with military in US and Canada, do some work with various other groups, and you start talking about yoga nidra, and I have tremendous respect for all the ancient traditions and classical traditions. I do. But one problem that they have, and that science also has, is this intense obsession with cloaking concepts in complicated language so nobody can understand it, even though the taxpayers are paying for it. And so a big kind of mission of mine, I don't really like mission statements, but a mission of mine is to try and unveil the beauty and the utility of biology and place it in language that at least gives some sense of what we're talking about. So non-sleep deep rest is non-sleep deep rest. What does it involve? It involves the opposite of meditation, most meditations, where you're focusing on your breath, kind of trying to stay centered. That's meditation. Non-sleep deep rest is where you go, as they like to say in Yoga Nidra, from thinking and doing to being and feeling. I don't know why I feel compelled to do it in that voice. I love Yoga Nidra. You do this for about 10 to 30 minutes a day. I always say the best time to do it is first thing in the morning, in the afternoon, when you wake up at night, or any time. It has multiple positive effects. One, it teaches you to relax your nervous system deliberately. Two, it turns off your thinking, which is required to fall asleep. And so you get better at that. And three, it enhances neuroplasticity. And we now have some sense of how that's accomplished. There are a couple papers. One is that there's a replay of neural firing sequences during rest. This is an amazing paper. So during deep sleep, not non-sleep deep rest, but during deep sleep, you get a replay of your experiences throughout the day, and that's part of the memory process. And it's a rapid replay. It's almost like you're getting more repetitions of what you tried to learn over and over and over and over, right? Probably some of you, most of you I hope, are familiar with the beautiful, also Nobel Prize winning work of the Mosers, who are Norwegian. I think they're up in Tromsø. Did I pronounce that poorly? Anyway, something like that. Husband and wife, actually ex-husband and wife team, although I think they still get along. They have the Nobel to share, so I don't know. I'm not in that. But they did the work together when they were married, so anyway. That work showed that we have a map, for instance, of location in our brain, and that replays very quickly during sleep when we learn new locations. Turns out there's this replay during sleep. It also exists during rest. Just 20 minutes of naps. Should you nap? Yes, provided it doesn't interfere with your nighttime sleep, but don't make it longer than 90 minutes. That's going to throw off those melatonin and cortisol rhythms that I talked about earlier. If you're not a napper, no big deal. You don't have to nap. Then there's this paper. Oh, it looks like it got a little bit clipped there. Forgive me. Increased dopamine tone during meditation-induced change of consciousness. This is, to my knowledge, the first formal exploration of the neural effects of just lying there and listening to this script. You can access NSDR scripts or Yoga Nidra free online. They're all over the place now. It's not my voice. That would be weird. But you can just listen to these 10 or 30 minutes long. What happens? Well, some of you may know what this is, but most of you probably don't. This is a positron emission tomography image, and so is this one. They use a drug that binds to dopamine receptors. So when you see less binding, what it means is there's more dopamine circulating. This was subjects that either did Yoga Nidra or did not. So just 20 minutes or so of lying there just in deep relaxation. This was work that was done in London and in Denmark. I'm assuming it was done in Denmark, but that you've got some Brits on this. We can probably guess that David Brooks was one of the Brits. I won't attempt to, that was my way of avoiding trying to pronounce the other names. The reduced binding of this thing, doesn't matter what it is, radioactive raclopride, doesn't matter, was translated into, in a very concrete way, a 65% increase in circulating dopamine levels in the brain. 65%. Specifically in the circuits of the brain that are responsible for attention, readiness, and action. The so-called basal ganglia, for those of you that want to know. Amazing. Just rest, but it's rest of a very particular kind where there's no what? Well, there's still a heartbeat, there's still breathing, there's still digestion. What is being and feeling as opposed to thinking and doing? Right? What is that in neuroscience? You turn off the prediction stuff. You're stopping the narratives. You're not predicting what's next. And this is very distinct from meditation, which is about focus. Meditation often involves intense focus. So this is a powerful tool to use anytime to enhance learning and improve your ability to sleep and to regulate your nervous system and reset dopamine levels. Amazing work that we're now following up on also at Stanford. Meditation is different. Most of the data on meditation, and there are lots of it, is that it increases your ability to focus, which is good for the learning process and for other reasons. There's a lot of ADHD out there. A lot of people think they have ADHD, but actually what people have is this thing called a smartphone. And it's trying to create ADHD, and not just in kids, in adults too. I actually am I'm not just saying this, I'm positively tickled, I guess would be the word. I always want to use that word. I've been tickled by, I look around Copenhagen and I would say 90% of people are not on their phone compared to the number of people that you'd see in a similar density environment in the United States. Remarkable. So maybe it's just a problem we have in the US, but I have a feeling that it's not. Meditation, even 10 minutes a day meditation has been shown to, as this title suggests, in a beautiful paper by Wendy Suzuki, who is soon to be Dean of Arts and Sciences at NYU and an incredible memory researcher. Brief daily meditation enhances attention, memory, and emotional regulation in non-experienced meditators. 10 minutes. But guess what? It also disrupted sleep if done too late in the day, because meditation is a practice in directing your attention over and over again back to your breath. It's not really a relaxation exercise. It's more of a focus exercise. At least that's what most of the data show. And I did want to mention that it can disrupt sleep if done after, say, 8 p.m. or within 4 or 5 hours of sleep, because you need to turn off your ability to focus. Some of you might be able to meditate and go to sleep. Great. But for those of you that have challenges with sleep and you're using meditation as a tool, maybe try shifting it earlier in the day. I'm almost done and able to take questions, but I wanted to mention something else, which is that neuroplasticity during non-sleep deep rest can be done after some sort of attempt to learn, but there's something else you can do after an attempt to learn, and that's spike your adrenaline. Beautiful work from Larry Cahill and James McGaugh, two incredible memory researchers that has worked on in animals and in humans, showed what in medieval times was already known. Did you know this, that in medieval times they used to teach kids lessons and then they'd take them and they'd throw them in the river? They would. There's historical evidence of this. I wish I were making this up because it was kind of funny, but then I tell you as a joke, but it's not. They used to do this. They would shock their system with adrenaline in order to stamp down learning of what they had just learned. Most of us do this all wrong. we drink coffee, we get really excited, okay, now we're gonna learn. It's post-learning, within 5 to 15 minutes, spiking of adrenaline that stamps down that previous round of experiences as important. And if you think about trauma or fear type experiences, that's exactly what happens. You don't inject yourself with adrenaline and then have the scary thing. It happens during it, and then afterwards there's a big wave of adrenaline. It's something happens on the street and then it stops and and you have a hard time calming down. It's stamping down that experience. Well, that can be leveraged also for learning positive experiences. And then things like non-sleep deep rest can be used to further emphasize the learning, this neuroplasticity process. And this has been shown in data, improvements in reaction time after meditation or yoga nidra can be done. The point of this is really just say you don't have to do this immediately after. Your nervous system is a bit more flexible than that. The only thing that would have to be done immediately after learning is a spike in adrenaline, and you certainly don't have to do it every time. And then this is, in my mind, these are some of the coolest data I've ever seen, and I can say that because I had nothing to do with them, which is that rest even during learning powerfully increases learning. So there's a rich literature on this. I didn't know this until I started researching this for the podcast. This dates back 2 decades or more, that taking brief 10-second pauses amidst an attempt to learn. So maybe you're trying to learn scales on the piano. It's really frustrating. Just pausing and just doing nothing every once in a while at random greatly increases your ability to learn. So this is we've got a pre-training rest, post-training rest, and this is the inter-practice rest. So these little 10-second randomly inserted rest intervals. What happens? Well, in this study, they finally did the neural part. They looked in the brain, and what they found is that during those little rest periods, they see fast repetition of the same firing of neurons that occurred during the attempt to, say, play that scale or do that dance step, etc. That fast replay is exactly what you see in sleep. So these little micro rests during learning, non-sleep deep rest and during deep sleep, it's actually repetition, but it's happening only in your head, not from the actual performance of the sequence. Now, for those of you that are interested in how to implement this, it needs to arrive at random. So if you're a teacher, you can do this every once in a while, maybe ring the bell and just tell the kids to just zone out. And they're getting 20 repetitions for every repetition that you would have taught them or they would have performed. And then I always get the question, well, can we just rest? No, you actually have to trigger what gets repeated by some attempt to learn. Again, that 85% to 15% error rate, 85% correct trials difficult to 15% incorrect or failures sort of level of difficulty being optimal. Pretty incredible if you ask me. So you trigger neuroplasticity with focus, and the rewiring occurs during sleep, non-sleep deep rest, and in little micro rests that we take throughout learning. So if you're working hard and you can't seem to focus and you just take a pause, your brain is actually generating those repetitions, and it happens specifically in the hippocampus and the neocortex, areas involved in the formation and the storage of memories. So since this, I was told, would be put in some format someplace, I'm just going to put a huge list. I'm not a fan of lists. It's like my least favorite thing, list to do or lists of this or that. But I wanted to put all this here because there's a lot more to this. And I didn't want to take all your time, but I wanted to make sure that we at least understood, like, what would a neuroplasticity super protocol look like? What would that be if we're going to base it in peer-reviewed data? Not, microdose psilocybin or whatever, which, by the way, no evidence that actually causes neuroplasticity. I have a good friend at Johns Hopkins School of Medicine. He was on the Huberman Lab podcast. His name is Matthew Johnson. He's running the clinical trials on psilocybin for neuroplasticity for treatment of serious depression, trauma, eating disorders, and so forth. And I said, what's the deal with microdosing psilocybin? Does it work? And he said, well, no. He said, macrodose. Okay. I did not participate in that trial. I'm not telling you to macrodose, but it does seem that at least within the safety and the confines of a clinical arena, at least within the confines and safety of the clinical arena, with someone there to support, there are pretty incredible data on the utility of things like psilocybin, ketamine therapies, and MDMA. I'm not suggesting people do these. What I'm saying is that the data are very impressive, hence Big Pharma is kind of moving in on this soon, and I think it's very likely that these are going to be in the psychiatrist's toolkit very soon. But the notion of microdosing, there doesn't seem to be much data. But we can say Well, what are the protocols based on peer-reviewed science that are known to enhance plasticity and that we can all engage without having to ingest anything? I've listed them off. You want to get alert? We can talk about motivation another time. There are things like white noise, believe it or not, can enhance alertness. Not brown noise or pink noise for you nerds out there. They're like, what about brown noise? What about pink noise? You know who you are, all the engineers. Get focused, then generate repetitions, as many as you can safely generate in a given time. But repetitions, including making errors, is key. So expect and embrace errors. They sharpen your focus by increasing activation of the prefrontal cortex, because that, I got it wrong, that's the stimulus to learn better on the next trial. Unfortunately, we interpret that usually as I'm gonna stop or I'm not doing well. That's actually a brain state that you can leverage toward better learning. Randomly insert micro rest intervals. These are more neural repetitions. Don't think about them as rest, think about them as increasing repetitions. Use random intermittent reward, including no rewards at all. There's a lot of discussion, at least in the States, like, do you give every kid a trophy? Do you only give the winning kid the trophy? Look, we know the schedule reward that works for long-term motivation. It's called intrinsic reward, really wanting to do the thing. But unless somebody is intrinsically motivated to do something, what's the schedule reward that works? Think about gambling. It's random, intermittent reinforcement. Don't reward every trial. Don't reward every win. Every once in a while, withhold. And that includes your own self-reward. You succeed in something really great, every once in a while, clamp it, move on to the next thing. Every once in a while, celebrate that. Celebrate every win, and pretty soon, because of something called dopamine reward prediction error and some other elements of dopamine circuitry, you will be less motivated to perform that thing. There's very, very solid data to support that idea. Limit learning trigger sessions to 90 minutes or less. There's reasons for that based on so-called ultradian rhythms. We could talk about it. And then incorporate 10-minute non-sleep deep rest post-learning trigger sessions. Don't have to be immediately after. But things like reverie, which is self-hypnosis, which we didn't talk a whole lot about, but it's a very interesting practice of brain state that brings together both alertness and calm in the same session and can lead to more rapid plasticity. People get freaked out when you talk about hypnosis. There's a very simple way to know if you're highly hypnotizable, by the way. It's literally called the Spiegel eye roll test. It was developed by our Spiegel's dad, who was also Spiegel, obviously. And if you think eye stuff is weird for understanding the brain, just understand that we monitor concussion with these two little bits of brain by shining light in one eye. Pupil constricts, right? And they're looking at the other eye for the so-called consensual pupil reflex, although actually it should be called the non-consensual pupil reflex because it doesn't have a choice. If you have a healthy brain, the other one should constrict. It's one of the great mistakes that anatomists made, so I like to point it out. I don't know why. In any event, here's how you know if you're highly hypnotizable. If you can look up without moving your head, so not doing this, but if you can look up, it looks really weird to do this, but this is what they would do in the clinic to see if you're highly hypnotizable, which is actually a good thing. If you can look up and close your eyes without looking down while closing your eyelids, you're highly hypnotizable. It's literally the Spiegel eye roll test. You can look this up. This is a psychiatrist tool. Why? Why? Well, it turns out that the brainstem neurons that control upward gaze are involved in establishing alertness. And the brainstem neurons and other neural circuits that are involved in downward gaze and closing of the eyelids are involved in calmness and going to sleep. Duh. The first time I heard this, I was like, amazing. And then Spiegel was telling it to me, and he was like, well, it's obvious, right? These are two incompatible things. It's like opening and closing the door at the same time. And what is hypnosis? Self-hypnosis, not stage hypnosis, even though I'm telling you this from a stage. Stage hypnosis is about getting someone else to do something. Self-hypnosis is about taking your brain into the key state that triggers neuroplasticity and allows neuroplasticity, which is alert but calm, deeply relaxed, but very focused. And not everyone can achieve that state to the same degree, but everyone can achieve it. So if you can look up and close your eyes and keep in upward gaze, it takes a little work, right? It's sort of an active state. Then you are highly hypnotizable. And you're hypnotized right now. No, I'm kidding, you're not. Yeah. And then the last point is to maximize quality and optimal duration of sleep that night and the next and the next and the next. And if you want, we can talk about sleep and all that stuff. All right, as a final point and truly final point, mindsets are super interesting and super powerful, and I have to confess, this might be my favorite literature. This is my colleague, Dr. Aaliyah Crum, she goes by Allie, who's a tenured professor of psychology at Stanford. She was also a Division I athlete, and she was a licensed clinical psychologist. Like, who are these people? And definitely not one of these people. She just seems, and a super nice person, and an amazing human being all around. And her lab studies mindsets. And I'm just going to briefly summarize what I think are just important data that everyone should know about. Because you hear a lot about this. You hear about we should all have a growth mindset, which we should. We should all be gritty, which we should, presumably. We should all be whatever. We should think this way, be this way. But what Ali's lab has shown in beautiful studies is that if you take people, for instance, and you give them a movie about stress, and you tell them all the terrible things that stress does to you, and then you give people the same movie, different people the same movie, you tell them all the ways that stress can enhance your immune system and make you better, et cetera, guess what you see? Exactly what they learned. These are mindset effects. These are not placebo effects. These are knowledge-based effects that compound the real physiological effects of stress, but change the direction of their effect. And in an even more kind of spooky way, if you take people and you have them exercise in exactly the same way, and you tell one group, exercise is good for you, and you tell the other group, exercise is good for you, you'll lose weight, your blood pressure is going to go down, your blood sugar regulation is going to improve, guess what? You see significant differences and improvements in things like weight loss, blood pressure, et cetera, for the group that was informed what the exercise would do. For the same exercise. Wild. You can even give two groups milkshakes. You tell one group, hey, this milkshake's filled with nutrients, got a lot of sugar and fat and protein, it's gonna keep you full for a long time. Give other people a shake and you say, this is a healthy shake, it's good for you. And then you measure things like insulin response or ghrelin, a hormone that's associated with hunger. And guess what? The people that got the shake that's, it's a good for you shake, their insulin response is lower. Their ghrelin response comes on sooner, so they're hungrier sooner. It's the same shake. So our knowledge about food is really important too. And this turns out to be very important. If we think we're eating something because it's a so-called diet food, we'll be hungrier sooner. So there's all sorts of implications. This has been done with other things like drugs, whether or not you think side effects are evidence that something is working or is not working, and the outcomes of those drugs. Powerful stuff. She's doing beautiful work, and I'd be remiss if I didn't mention it. So I'm going to stop there, and I'd love to and look forward to taking your questions. I end every podcast with the same way. Usually I say something about what we just talked about, but I'm not going to take any more of your time. I hope that what you found, or that information rather, was informative, at least toward some of your mental health, physical health, and performance goals, and if not yours, maybe other people's. Again, these are all mechanisms that you have installed in you already, right? There's nothing to take, there are only things to do should you choose. And as I always finish the podcast, last but not least, thank you for your interest in science.